This is Algebra 2 with Trig. This is the Unit 3 review, working on page 6. So these particular questions here, the complex fractions, on our test for this, we'll have to do this as a short answer. So you'll have to do this by hand. It's not a multiple choice option. So what we're going to first do is I would notice here and I would factor that. So I would suggest factoring these down. Now I'm looking for my LCD, least common denominator, for all of these fractions. So it looks like a 2, an x, and an x minus 1. That would be our LCD. So we would multiply every one of these fractions, 2x, x minus 1, 2x, x minus 1, and 2x, x minus 1. You multiply it to all the fractions. Then we reduce. So this is going to make 4 times x minus 1. This is going to make 6x. And this is going to make x. So we'd get 4x minus 4. And then we'd get 10x minus 4 over x. Now do notice you cannot reduce the x's because it's on one side of an addition or subtraction sign. You cannot reduce that. So that's our answer. Let's try it again. So I'm going to look for an LCD. I'm looking at all three denominators. So I have a 3, I have an x, and I have an x plus 2. So I'm going to multiply that to all three fractions. 3x, x plus 2. Then we can reduce. So we can reduce there. And we get 3x times 3. And we can reduce the x's out of there. So we get 2x and x plus 2. We get 6x squared. Now you got to be careful here because there's a minus sign. So we'd have 3x plus 2. So that's going to give us 9x plus 2x squared plus 4x. This gives us 6x squared, 3x and take a negative of that, and 6 and take a negative of that. So I notice there's an extra x in here. We could pull that out if we wanted to. No, hang on a sec. Let's retry that. These are our like terms. So let's collect our like terms together. 2x squared plus 13x. And let's pull this 3 out. 2x squared minus x minus 2. That does not look factorable. You can't multiply to be negative 4 and add to be 1. Alright, so there's we are. Interesting. LCD. It's going to be 4x and 2x minus 1. So we're going to multiply that to all of them. So here it looks like the 2x minus 1's cross off, and I get 12x squared minus, there's no denominator, so that's going to be 2 times 8x squared minus 4x. I'll deal with that negative here in a second. Cross those off, and I get 5 times 2x minus 1 minus the x times the 4x. So keep simplifying this down a little bit. 12x squared minus 16x squared plus 8x. This looks like 10x minus 5 and a negative 4x squared. So that's giving us a negative 4x squared. This is a positive 8x. This is a negative 4x squared plus 10x minus 5. Even if this wasn't negative here, you can't multiply to be 20 and add to be 10. That's all I see. All right. And then our last one, looking at the LCD, it looks like 20x squared. So we do 20x squared, each one of these. The 20 and the 5 are going to reduce. The x squared is going to reduce. The 5 is going to reduce with the 20. The 4 is going to reduce with the 20. So that's going to give us 4x squared minus 100. Ooh, this is a weird one. This is 4x to the 4th. And a positive 5x squared. Looks like I can pull a 4 out of the top. I can pull an x squared out of the bottom. That doesn't factor anymore. That one does, but it wouldn't reduce with anything. So that's the best we can do. If you would like to factor the top, you could factor the top. The bottom does not factor. Nothing crosses out. Next we'll look at number 21. Here we're looking for errors in the work. You got to get kind of creative on what they may have done, but it looks like they tried to cross the x's off. And they try to cross the 1's out. So then essentially you'd have 1 minus 1, which is 0. You can't simplify that. That's the error. What is the correct thing to do? Would be to multiply by, is to get common denominators. That's what we need to do, is get common denominators. So this side would need an x. So that would leave us 1 over x minus x squared over x, which is 1 minus x squared over x. And you could write that differently. If you would want to write that as x minus 1, x plus 1 over x, you could do that. I pulled the negative out, which made the x squared positive and made the positive negative. And then that is the difference of two squares. Let's see what they did here. Here they just added. They added for fun. They just added the x plus 4 and they said, there's my denominators. But they need to create common denominators. All they did was write a denominator with a combination of the two. But what you would have to do is multiply both of them. So we'd have x plus 2, and 4, x minus 5. So we're going to say x minus 5, x minus 5, x plus 2, x plus 2. That gives us x squared minus 5x and 4x plus 8. And that looks like we can bring this together a little bit and say x squared minus x plus 8 over x minus 5, x plus 2. The top can't be factored. Can't multiply to be 8 and add to be 1 or negative 1. Alright. Down here they're asking, is 3/2 actually an answer to this? So you could do the whole problem and see if it was an answer. But really all we have to do is to plug this in for the denominator. Does it make 0 down here? When we plug 3/2 and square it, that doesn't make 0. That definitely doesn't make 0 for 3/2 plus 4. But 3/2 here, that makes 0. So this is extraneous. So it is not a real 0. That's an extraneous answer because we get 0. So no, that is not a solution. Four looks like it works here, it looks like it works there, it looks like it works here. So I would say 4 is correct. We could test it. 4 over 4 plus 4 minus 2 over 4. Does that equal 2 times 4 minus 8 over 4 squared? This is going to be 4 over 8 minus 4 over 8 equals 0 over 16. Yep, that worked.